The example for chapter 3 on page 18, the last page of the notes, says a cylindrical can is to be constructed to hold a fixed volume of liquid. The cost of the material used for the top and bottom of the can is 3 cents per square inch, and the cost of the material used for the curved side, which is a rectangle, is 2 cents per square inch. Use calculus to derive a simple relationship between the radius and height of the can that is the least costly to construct. So this does say again, least costly, and so we know we are minimizing something, and when we are minimizing something, that means that we are going to take a derivative. And then we have, since this is a cylindrical can, I drew that over there on the right side, and I did write down the volume function. Those functions will be given to you on an exam. However, on homework, you might have to look those equations up. And so volume is equal to pi r squared h, where r is the radius, and h is going to be the height. And so if you look at the top and the bottom of the can, they are going to be circles. And then if you were to stretch out the middle part that wraps around the can, it's going to have a height, h, and that length around there would be the circumference, which is going to be 2 pi r. And so let's go ahead and just define our variables. I'm going to zoom in over here. So we're going to let r equal the radius. We're going to let h equal the height. V is the volume. And we're going to call C the cost. And we're going to say this is in cents, since that was the units that they were giving us in this problem. So the cost, our cost function, is going to equal the cost of the top plus the cost of the bottom. And again, those two parts are circles, plus the sides. So the cost of the sides. So from here, we have the cost of the top. It says that the cost is going to be 3 cents per square inch, and that is also going to be the cost of the bottom. So that's for the top and the bottom. And the area of the circle that we have, so the area of a circle is going to be pi r squared. And then the side cost that we have, that was the area of a rectangle. And the rectangle, again, that we have that was drawn over on the side has a height, h, and then the length is going to be 2 pi r. And so to find the area of a rectangle, it's just going to be the length times the width, and you end up with 2 pi r times h. So the cost of the top is going to be the area times the cents per square inch. And so we're going to have 3 times pi r squared, plus the cost of the bottom is also 3 cents. And again, pi r squared. And remember, I did put down that cost is written in cents, so I don't need to change that to a decimal. And then if you look at the cost of the sides, it does say that that is going to be 2 cents per square inch. And so zooming in again, we have plus 2 times the cost of the sides, which is going to be 2 pi r h, which is our area. So simplifying this, our cost function is going to be rewritten as 3 pi r squared plus 3 pi r squared would be 6 pi r squared plus 4 pi r h. And like we saw earlier, we do have two variables. Remember, pi is actually a number. It's 3.1415 and it continues on. And so since I have two variables, I need to think of a way to rewrite this with just one variable. So it's just like the previous example. And we do know that our volume is equal to pi r squared h. I'm going to go ahead and solve for h because that's the easier variable to solve for. And that means I'm going to have v divided by pi r squared. So now I'm going to take my height formula that we have, and I'm going to substitute it in over here for h. So when we do that, we have our cost function is going to be 6 pi r squared plus 4 pi r times h, and h is going to be v over pi r squared. from here, we can simplify this, and our cost function is going to become 6 pi r squared plus, you notice your pi's would cancel, one of the r's would cancel, and we end up with 4v over r. I'm going to rewrite that as 4v times r to the -1 since it's in the denominator. So we have a simplified function for our cost, but if you notice we still have two variables involved in this. I have r's and I also have v. Now back up at the words, you will notice that it holds a fixed volume of liquid. And so that means that volume is fixed, and fixed means that it is a constant. That means it's not a variable. And so when we take a derivative of our cost function, you can think of it as just like a number. So 6 pi r squared, taking the derivative with respect to r, is going to be 12 pi r plus, and then we're going to multiply by -1 out in front. That's going to become -4. V is just a constant, r to the -2nd. And then we're going to figure out where this is minimized, is going to be setting this equal to 0. We have 12 pi r plus, and I'm going to rewrite that with a negative, so minus 4v over r squared is equal to 0. And then going ahead and solving this for r, we're going to have 12 pi r equals 4v over r squared. Multiplying both sides by r squared, we have 12 pi r cubed equals 4v. Remember, our volume v is fixed. Solving for r, I'm going to divide both sides by 12 pi. When we divide both sides by 12 pi, we can simplify our numbers. And we have r cubed equals, so we have v over 3 pi. And then I need to take a cube root. Now whenever you take a cube root, you don't need to put a plus or minus because you could take cubes of any value. So we arrive at our radius is going to be the cube root of v over 3 pi. So looking back out the directions up at the top, it does say it says use calculus to derive a simple relationship between the radius and the height of the can that has the least costly to construct. So right now we have our radius, and in order to find our height, I will need to plug this back into something in order to get it. And I do have a height function, if you go ahead and look right up here in the upper right, and that's the volume over pi r squared. And I'm going to go ahead and substitute in what r is here. And so we're going to have volume over pi. R is going to be the cube root of v over 3 pi squared. And so this would be our height. You can simplify it from here, but I will say this is fine to leave. So we'll go ahead and say that h is going to be v over pi times the cube root of v over 3 pi squared. And we are dealing with inches, so make sure we put inches on both of these. And we can check to actually make sure that this is minimizing our cost, but we'll go ahead and just take this as a given and say that these are our answers.